our question is from group 46. The question has given us the fx, which is x minus 1 to the power of 1 over 2 and x plus 2 to the power of 2 over 2. The question asks us to find critical numbers. So, to find critical numbers, we need to differentiate the equation first using product rule. Product rule, you can use it UV prime plus PU prime, and then after differentiate, you can factor out the numbers that can be factored out, and inside the bracket you need to simplify it, and then it will come true. So after differentiate, you can find the critical point. Let fx equal to x equal to 0, and then you can find the value of x, which is 0. And for the denominator, you can find the x using x minus 1 equal to 0, x plus 2 equal to 0. And you can see that fx is undefined when x equal to 1 and x equal to 2. So our critical numbers are x equal to -2, 0, and 1. And for the B question, the question asks us to find points of fx that has relative maximum. So first we can do the table, which has interval f prime x evaluated, sign of f prime x, and behavior of f prime x. Since we already got our critical numbers, which is -2, 0, and 1. So in between negative infinity to -2, you can choose any numbers that are between the numbers that I said. So here I choose -3, and -3 you can insert it into f prime x, which is this. So after inserting, I got 1.10, and the sign of fx is positive. Since the sign is positive, so the behavior of f prime x is increasing. Same goes to this. These three, choose a number, then insert, see the sign, and then behavior. As you can see that the behavior here is increasing, decreasing, increasing, and increasing. So since as you can see, the increasing, decreasing, you can see that there is a point here. So this is what we call maximum, and here is minimum. So our relative maximum is -2 here, and minimum is 0. Here is 0 and -2. So using the original equation, you need to insert the x, sub into the original equation, then you get the point. So these are the 2 points that I got. Point of the relative maximum are -2, 0, and 0, with root of 4. That's it.
Thank you. For 1C question, find the intervals on which function fx is increasing or decreasing. So in this question, to find the interval, whether it is increasing or decreasing, we need to do a table. So inside the table, we need to include the intervals, the first derivative function. We need to evaluate the first derivative function, the sign of the first derivative function, and also the behavior of the function. So we already know what is the first derivative of a function because from the previous question in 1a. So the first derivative is 0 at x equals to -2, x equals to 0, and also x equals to 1. So these are the critical points which subdivide the domain function into intervals of -infinity to -2, -2 to 0, 0 to 1, 1 to infinity. So we can put this interval into the table like this. So for this first column in the interval, I choose -3 to be used to evaluate the first derivative function. So from this first derivative function, we substitute the negative into it and calculate it, and we will get we will get 1.1906, which is more than 0. This means the sign of the first derivative function is positive and the behavior of the function is increasing. Next, for interval -2 to 0, I choose -1 to be used to evaluate, and substitute into the first derivative function, and I will get -0.6299, which causes the sign of the first derivative function is negative, and also the behavior of the function is decreasing, and followed by the next intervals. This one I choose 0.5, for this one I choose 2, and when I evaluated, both get the numbers higher than 0. It's more than 0, which means the sign of the first derivative function is positive, and also the behavior of the function is increasing. So from here we can conclude that the interval on which function which is increasing, the interval which is increasing in the function is intervals of -infinity to -2, 0 to 1, and 1 to infinity, whereas the intervals for -2 to 0 are decreasing. Next question, plot the graph using GeoGebra. So in GeoGebra, I will insert the function and also the critical point. We'll show the vertical line.
Assalamualaikum, my name is Yasmin Umaira. Matrix number is BC0530088. Today I would like to present question number 2. So the question number 2 said that two parallel off-side rectangles are being lengthened at the rate of 2 inches per second, while the other two sides are shortened in such a way that the figure remains a rectangle with constant area A is 50 inches square. So dt, x is the length, y is the width. So this is my x and this is my y. So we know that the area of rectangle formula is length times width. So I write x times y. So this is the formula, and this is my first equation. We also need the parameter. The parameter is x plus y plus y, because we need to plus all each sides. So back to the question, what is the rate of change the parameter p when the length of increasing sides is 5 inches? So we need to find dp dt. dp dt is rate of change parameter. So from the equation, this is my second equation. So from the equation 2x plus 2y, we need to differentiate to be 2 dx dt plus 2 dy dt. We already know that x is 5 because the question asks for 5 inches. So when x is 5, we substitute in first equation. This is first equation and this is second equation. So we substitute into first equation, which is 5y equal to 50. So we got 5 and we got y equal to 10. from the area, we need to find the rate of change of area. So we know that the area is xy. So we have to use a product rule, which is from the area formula. We know that is xy. So we need to use product rule. So to use product rule, we have to use this. U is equal to x, v is equal to y. U is dx dt, v prime is dy dt. So we need to cross it and plus like this, dx times dy dt and y times dx dt. So it will be like this. So why it is 0? This is 0 because from the question it already said that a rectangle with constant area A is 50. If it is a constant, so when it is a constant, the rate of change of area is 0. So this is our final equation. The next, so we already got the x is 5, y is 10. From this, 2 is dx dt, which is this one. From the equation, this one. Now we have to find dy dt. So dy dt, we need to place this and here. So we got negative 5 inches per second. So the question asks for the rate of change of parameter. So we need to substitute the formula of perimeter, rate of change of perimeter from this. So the dx dt, we already got 2 from the equation. This one is from the formula, negative 4. We already got here. So the final answer is negative 4 inches per second. So rate of change of perimeter is decreased by 4 inches per second because it is have negative here. Negative means decrease. Next question is B. We have to do the same thing as in A, which is but we just change it to 10. So we know that x is 10, and from the formula of the area is A is equal to xy. We substitute x is equal to 10 in the formula, which is 10y. So we got y equal to 5. So from the formula of area, we have to find the rate of change of the area. So the rate of change of the areas, we already know it is 0 because it is constant. So x is 10 from the equation, y is 5, we already got, and the x dt is 2 from the statement. So we have dy dt is equal to negative 1 from this. So we have to find the rate of change of perimeter. We have to substitute. This one is from the perimeter formula. This one is from the statement. This one is from this one. So the final answer is 2 inches. So rate of change of the perimeter is increased by 2 inches per second because it is a positive. Last question. It asks about what are the dimensions when the perimeter ceases to decrease. It means it minimizes as a limit. So this means that the rate of change of perimeter is 0 rate of change of perimeter is 0 because it ceases to decrease. So the same formula we use, which is 2 dx dt plus 2 dy dt, it is a rate of change of perimeter. And the dx dt we already know is 2 inches per cm. This is our first equation, which is equation from the perimeter. And we also know that the rate of change of area is 0 because it is a constant. So this is our second equation, the area equation. So 2 is from the dx/dt because we already know the dx/dt is 2. dy dt is we got from the second equation, from this equation, and we just do the algebraic method, which is negative 2y over x. So from the perimeter equation, our first equation, we already times this y. 2 times 2 is 4, and 2 is from here, and this one we just substitute dy dt into this equation, into the first equation. So we know that dp dt is 0, so we just simplify it by divide it by 4. So after we divide by 4, we got y is equal to x. So when y is equal to x, so from the formula, area is equal to xy, meaning x equal to y and y equal to x. So x here is actually y, same value, which is y, same value as x. So to conclude it, I just put x power of 2, and we know that area is 50, so we just got from here x square, we just square root it to get the x. So x is equal to 5 square root 2 inches. So 5 square root 2 inches is 7.07. So that's the final answer. It's basically a square. Why it is a square? Because it's same formula for the area. Area of square is here, right? It's just same thing, right? So when it's power of 2 is equal to area of square. That's all for me. Thank you.
So, question 3. The total cost of producing X radio sets per day is Rm1/4 x square plus 35x plus 25, and the price per set at which they may be sold is Rm50 minus 1/2x. For the question A, it asks that what should be the daily output to obtain a maximum total profit. So we list the information that we get, which is total cost to produce X radio sets per day. So we get this one, and then price per set is this one. So to calculate profit, we will use this formula, which is total revenue minus total cost. Revenue is the amount of money gained when product or service sold. So, as we can see here, the total revenue is price per set multiplied by number of sets sold. So, we get revenue equals to 50x minus 1/2x square. So, we will go back to how we get profit, which is total revenue minus total cost. So from the revenue value that we get, we will subtract it with total cost. So we get minus 3/4 x square plus 15x minus 25. to find the minimum or maximum value of the total profit, we will use differentiate. We will differentiate the profit value that we get. So we get minus 3 over 2x plus 15. And then we will equal the value that we get with 0 to get the value of x. So we get 10. And then we will do second derivative, which we will get minus 3 over 2. So since minus 3 over 2 is less than 0, this indicates that P10, profit 10, is maximum value. So the daily output to obtain maximum total profit is 10. So for the question B, the question B asks for cost of shows that the cost of producing a set is a relative minimum at the output. So cost per set is equal to cost to produce X set divided by X. So we will get 1 over 4 x squared plus 35x plus 25 divided by X. So we will get 1 over X plus 35 plus 25 over X. So we will, to find the minimum, to prove that it is relative minimum value, we will do differentiate, and then we will get 1 over 4 minus 25x power of minus 2, and then we will equal the answer that we get from the differentiate to 0, and then the value of x that we get is 10. So we will differentiate s to second derivative. So we will get 50 over x minus 3. And then we will substitute 10, which is the value of x that we get when we equal x first derivative with 0 into the x second derivative. So we will get 1 over 20, which is more than 1 over 20 is more than 0. So this indicates that as second derivative 10 is maximum value. So the cost to produce a set is the relative minimum to the output. That's all.
So for question 4, evaluate each of the following limit using L'Hopital rule. So Roman 1. So the first question is limit x approaches 0 of sine x over 4x. So we need to substitute the 0 into the x into this function. So after we substitute, we get the indeterminate form, which is 0 over 0. So we use L'Hopital rules. So limit x approaches 0, we need to differentiate the numerator and denominator. So sine 3x we differentiate, we can get cos 3x times with 3, and 4x we differentiate, we get 4. So now the function we get is limit x approaches to 0 of 3 cos 3x over 4. So from this function, we can directly substitute the 0 to the function, and we can get the answer 3 over 4. So for the question 2, limit n approaches to infinity of 3e to the power of 2n over 4n to the power of 2. So after we substitute this infinity to the n, we get the indeterminate form, which is infinity over infinity. So now we need to use L'Hopital again for this question, and we need to differentiate the numerator and denominator. So if we differentiate the 3e to the power of 2n, we will get 3e to n times 2 over 8n. So after that, we need to simplify, we need to calculate this one, and we can get 6e to the power of 2n over 8n. So in this case, if we substitute the infinity to the n, we get the indeterminate form again, which is infinity over infinity. So in this case, we need to apply the L'Hopital rule for the second time. So now we need to differentiate the numerator and denominator again. So we will get the 12e to n over 8. So now we can directly substitute the infinity to n. So we will get infinity.
Our question number 4. Evaluate each of the following limits using L'Hopital. For question 3 Roman, limit x approaches 0 from right, x to ln x. We rewrite to use L'Hopital rules. So limit x approaches 0 from right, ln x over 1 over x power of 2. Then we differentiate our numerator and denominator. After we differentiate, we get 1 over x, and also for our denominator is negative 2 over x power of 3. Then we simplify 1 over x times with x power of 3 over negative 2 equals to x power of 3 over negative 2x. Then we insert in our equation. So limit x approaches 0 from right, negative x power of 2 over 2, and the answer will be 0. Next, for question, this one for Roman. So limit x approaches infinity and exponent to n. We rewrite to use L'Hopital rules. So limit x approaches infinity n over exponent to n. So there will be infinity over infinity. Then we use our L'Hopital rules. But first we differentiate. We use fx equals to u prime times with exponent u. So our u is 2n. And we differentiate our u prime equals to 2. So fx, we got 2 exponent 2n. Then we insert in our equation. We got limit x approaches infinity, 1 over 2 exponent to n, and the answer will be 0.